Welcome to Morphic Labs, and today we are going to be discussing advanced correlation for markets. More specifically, we're going to be talking about topological data analysis, persistent homology. But before we get into that, do me a favor, hit the subscribe button if you want to keep out more content like this. I would greatly appreciate it. And if you're interested in increasing your market intelligence, which if you're into trading or markets in any capacity, you should be interested in increasing your market intelligence. If that sounds like you, the free market microstructure and 10 systems course that will walk you through the foundations of market structure, the mechanics of trading market data, and analytics, everything from market structure and trading venues, order types and execution, to liquidity and market impact. All the things that a serious market participant should know. Plus, if you're into looking at markets from different angles, I have a free advanced market aggregation course that will walk you through advanced price-based aggregation and volatility-driven aggregation, information theoretic aggregation, order flow microstructure aggregation, event-driven and hybrid methods, plus implementation and selection criteria so you can pick the most optimal aggregator for your specific use case. If you found that interesting, the links are in the description. Just sign up to be a free member, and you have both of these resources all to yourself for free. Now, let's get into it. Chapter 7, Topological Data Analysis. This one's going to be a short one, but in the next video, I'm going to be essentially applying persistent homology to a set of different data sets, more specifically financial data sets, just to look at the topological dynamics of those data sets. But for now, let's look at technicals. Topological data analysis, TDA for short, offers a fundamentally different approach to understanding correlation structures by examining the shape of data rather than its parametric properties. Persistent homology, the flagship tool of topological data analysis, tracks how topological features, connected components, loops, voids evolve as scale parameter varies. Given a point cloud in a metric space, I'm assuming you already know what a metric space is. If you don't, a metric space is just a set endowed with a distance function, right? Given a point cloud in a metric space, construct a filtration of simplicial complexes. I'm also going to assume you know what a simplicial complex is, right? If you don't, look it up. But yeah, construct a okay. Given a point cloud in metric space, construct a filtration of simplicial complexes of k sub epsilon, where epsilon is greater than or equal than 0, where simplex is included at scale e epsilon, if all its vertices are within a distance epsilon of each other. The persistence diagram records the birth and death scales of each topological feature, with long persistent features representing genuine structure and short-lived features representing noise, right? And this is going to be more apparent in the next video when I actually apply this to actual financial data. Reference 12 applied persistent homology to financial time series, demonstrating that the persistent landscape, a functional representation of the persistence diagram, exhibits characteristic changes prior to market crashes. I'm going to read that again because it's extremely important. Reference 12 applied persistent homology to financial time series, demonstrating that the persistent landscape, a functional representation of the persistent diagram, exhibits characteristic changes prior to market crashes. And this just means that essentially the topology changes its shape before the market crashes, right? Specifically, the L2 norm of the persistent landscape increases significantly in the days and weeks preceding a critical transition, providing an early warning signal, right? Because when you look at the topology, the shape of the market, you're not really concerned about what the volatility is, what the price is, what the order book says, what the news say. You don't really care. The only thing you care about is the shape of the overall geometric structure, right? Reference 13 extended this analysis to cryptocurrency markets, showing that the topological features of Bitcoin price dynamics exhibit similar precursor patterns before major corrections. The Betty numbers B sub k, which count the number of k-dimensional holes in the topological space, serve as summary statistics, where B sub 0 equals the number of connected components and B sub 1 equals the number of loops, and it goes on and on and on, right? Market application. Prior to February 2018 cryptocurrency crash, the L2 norm of the one-dimensional persistent landscape for Bitcoin increased by 340% over a 10-day window. Similarly, before the March 2020 equity crash, the persistent entropy of the S&P 500 correlation matrix dropped sharply, indicating a collapse toward a single connected component as all assets become correlated, right? So essentially, you can use topology or persistent homology to essentially observe the shape of the market change relative to where it is right now, right? And here are some of the advantages and limitations of this type of correlation. The advantage is number one, model-free detection of structural changes, right? You don't need any parameters or any fitting of data, right? I don't need to fit a model to data. So what the advantage is model-free detection of structural changes. Number two, provides early warning before crashes. How many correlations can you say can give you an early warning before a crash? Not too many. Not too many. So you should have this tool in your quantitative toolkit. Number three, robust to noise and outliers. Number four, captures high order dependencies. And the limitations of this type of correlation, number one, computationally expensive for large data sets. Yes, it does take a lot of compute to essentially uh, apply persistent homology to very high dimensional data sets. Number two, requires expertise in algebraic topology. True, because if you don't know topology, algebraic topology, point set topology, um, you're essentially walking in with your eyes closed. So usually this type of correlation is used by mathematicians or individuals who are very mathematically mature. The third limitation is limited off-the-shelf software. So there's very little off-the-shelf software that will apply persistent homology for you, right? And number four, interpretation requires domain knowledge. Of course, interpreting the results of the persistent homology requires you not to only know algebraic topology and other forms of topology, but to also know uh, what the application of the persistent homology even means for your specific data set, right? And that's about it for today. If you found that interesting, hit the subscribe button. I would greatly appreciate your support. And if you're interested in increasing your market intelligence, which if you're into trading or markets in any capacity, you should be interested in increasing your market intelligence. If that sounds like you have a free market microstructure and trading systems course to walk you through the foundations of market structure, the mechanics of trading, market data, and analytics, everything from market structure and trading venues, order types and execution to liquidity and market impact, everything every serious market participant should know. Plus, if you're into looking at markets from different angles, of a free advanced market aggregation course that walk you through advanced price-based aggregation, volatility-driven aggregation, information theoretic aggregation, order flow microstructure aggregation, event-driven hybrid methods, plus implementation and selection criteria, so you can pick the most optimal aggregator for your specific use case. If you found that interesting, the links are in the description. Just sign up to be a free member, and you have both of these resources all to yourself for free. And that's about it for today. Hit the subscribe button. I would greatly appreciate your support, and I am out. Bye.